Good evening, everyone. So welcome to this Ananthakrishna lecture series. So today we have Dr. Mandira Shrestha. She's a senior water resource specialist at International Center for Integrated Mountain Development, which is IC mode, which is in Nepal, which is a famous institute for taking up a lot of mountain research. They have a lot of collaboration and they're involved in a lot of report making and all. So she's there from 2001 as per the profile says, yeah. So she's having a lot of experience, more than 25 years of research experience. So her main area of expertise is flood forecast, monitoring, hydrological modeling, and early warning systems. She holds a doctorate in engineering from Kathmandu University, Japan, and have a master's from University of Washington. And she took bachelor's in civil engineering from IIT Roorkee. And she's one of the leading of the famous Hindu-Kush Himalaya assessment report, which published a couple of years back. And she's contributing author of IPCC SOC reports. And she's a focal point for CORDEX South Asia program. So, madam, welcome to IITM officially, and you may take 30 or 40 minutes for. Okay, yeah, okay. And stage is all yours. Yeah, please go ahead. So she will be talking on something related with the climate services and a lot of institutional capacity building and so on. Please, yeah.
You want me to speak here?
Yeah, you can. Either you can use this. You want a collar mic or
this is awesome.
Yeah. Okay.
Thank you very much, Dr. Sabine. Very good afternoon to all of you. It's indeed a pleasure to be here in the IITM campus again. Just about 1 year before I was here for that international conference that we had on CORDEX, and now just 1 year after I'm here again to discuss CORDEX related issues with our colleagues here from IITM. As I said, I'm from EC Mode, the International Center for Integrated Mountain Development, located in Kathmandu, Nepal. And I'd like to thank all of you here present to be here for this presentation. And particularly, I thank Dr. Sabine for all the arrangements and making it possible for me to be here, and also for this presentation. And Dr. Sanjay, who's been always there in terms of supporting the work that CORDEX does. And of course, Dr. Krishnan. So there are many here that I can thank. But just before I start my presentation, I'd just like to see us, hands who have been here for the CORDEX workshop, the international workshop last year. Did any of you here present? Who are present? I see a couple hands. Yeah, a few hands. Good. So it's also good to see that there are some that haven't, many who haven't been here for the international conference, because I would like to, talk about a very important issue that's looking at climate services in the whole Hindu-Kush Himalayan region, and then particularly talk about one of the activities that we have done as part of the CORDEX South Asia activities, that is the institutional capacity building, looking at the spatial and temporal variability of precipitation, as well as various climate change analysis using CORDEX data sets, temperature, of course, also over the South Asia. Yes, so that's my presentation. So, yeah. So, to those of you who are not familiar with the Hindu-Kush Himalayan region, I'd like to introduce you to the HKH region. We call it the HKH region in short. So this is an area that spreads across 8 countries all the way from Afghanistan to Myanmar. So it covers Afghanistan, it covers Pakistan, China, Nepal, India, Bhutan, Bangladesh, and then Myanmar. So these are the 8 countries, and roughly we are looking at a distance of about 3,500 kilometers from west to east. And this region, as you can see here in the diagram, in the map, houses about 240 million people immediately in the region, the one that you see in dark blue in the map here, and downstream, we have more than 1.6 billion. So a total of close to 1.9 billion people basically are there in this region that depends on the resources from the Hindu Kush Himalayan region. Now, we all know that this particular region is the youngest geological formation. So therefore, we are very active tectonically. There are a number of earthquakes that happen, on a regular basis. The recent ones that I remember, at least I was part of, was the 2015 earthquake that occurred in Nepal. That was about the 7.9 Richter scale. But apart from that, there have been also many other similar earthquakes in China, like the Sichuan earthquake, and in Afghanistan and Pakistan as well, and bordering also India. So there's also the high spatial variation, both in terms of topography, as well as when you look at the climate. I'm sure I don't have to go into the details of the climate issues here, but I'd like to mention it, that there is huge variation. And given the fact that we have the largest amount of snow and ice outside the polar region, this edge cage region also gets the name called the third pole. So when you hear the name third pole, you can quickly think of the region that I just described, the Hindu Kush Himalayan region. So when we talk about, I'll directly go into the background in terms of the climate change in the Hindu Kush Himalayan region. And this particular report is actually, this particular analysis is from the study that was done by Dr. Krishnan as well as Dr. Sanjay as part of the HIMAP report. And here you can see the changes as far as the temperature trend is concerned. So you can see what the projected temperature changes as well as the mean temperature increase in the Hindu Kush Himalayan region, the whole region. And I think there has been another report that has been done, particularly just for the Indian region also. So you can see that for the two scenarios, that is RCP 4.5 and 8.5, we can see the temperature increase from anywhere from 2.5 to 5.5, by the end of the century. And then you can see also the schematics in terms of the diagrams. Now, what does the precipitation look like in the future? The same analysis done by Dr. Krishnan and his team shows that the increase in precipitation is likely to be 4 to 12% in the future in the Hindu Kush Himalayan region. And also that the extremes are going to be on the rise. Yes, and we are already seeing that. And there are many extreme events that are happening. And I will show you some examples of the extreme events that our region has faced recently. And then something that needs to be taken into note is that the western part tends to be drier and the Tibetan region tends to be wetter. So this is the study that has been done, again, by Dr. Krishnan using the data of CORDEX. So now let's look at what that all means when we talk about disasters. My focus is going to be on looking at disasters, disaster risk reductions, and extremes. Right. So when you look at the data regarding the disasters, there is a data set that is called the EMDAT database. Who here are familiar with the EMDAT database? Anybody here familiar with? Yeah, so Roxy is familiar with EMDAT. Anybody at the back familiar with EMDAT? Well, if you're looking at some impact studies, you want to know how many people are affected, how many people have been killed, right? So then it is a very important resource, useful resource that you should be aware of. It's called EMDAT, EM-DAT. And if you just type that, it'll easily come. You just have to register, and then you have access to a large volume of data regarding disasters. Yeah, so according to that disaster database, we looked at the last 30 years of data to see how the events as well as the people killed and economic losses varied. So you can see that looking at the typologies of different types of hazards. That is, if you're looking at whether floods or droughts or extreme temperatures, earthquakes, storms, or landslides, from the analysis, we found that more than 55% of all the events that have been reported in the Hindu-Kush Himalayan region are alone because of floods. So floods account to be number one in terms of the number of events. And then when you're looking at it in terms of the people killed, it does vary a little bit, but definitely again, in terms of the people killed by floods, it's 22%. And then in terms of storms, quite large numbers. And then economic loss is the largest, is accounted by floods alone. So then you can see, floods, is one of the biggest disasters that is occurring in our region. Continuing with that, if you're looking at the number of people affected, so you're also wondering how many people would be affected by such disasters, the same typologies of disasters here, you can see that more than 1.4 billion people have been affected by floods over the last 30 years. So that only accounts for 46% of all the events that have been reported. So large, huge, followed by droughts. Droughts is also, not very far actually, 34%, storms, and then earthquakes and extreme temperatures. Extreme temperatures definitely, landslides, mass movement. I put it all in one together, but that's also getting a lot of attention these days, particularly when you're looking at the heat waves that have been experienced in our region. So looking at what did that mean in terms of the changes in the flood frequency. So the analysis of some of the available climate change projection data sets. This is a study that has been done by Lutz et al. Here we see that the flood frequency of same magnitude almost doubled, by the end of the century. So that's quite alarming. Why is it alarming? Because it is directly related to many things, particularly to the design of the infrastructure. I'll give you an example of the Sikkim floods, for instance, that happened. Yes, that was a cloth, but again, huge volumes of debris came down and basically destroyed the hydropower projects that were there, and as well as many other infrastructure in place. So there is a need to relook in terms of even the design of the infrastructures in view of the changing frequency and magnitude of these events because of the change in the climate. Here, I try to give you some examples. I'm sure you are all familiar with and have seen these examples. The one that I have, the first is the Chamoli disaster in Uttarakhand, and this happened in February of 2021. And then this was a result of course, high altitude. Again, there was good afternoon, sir. Good afternoon. Welcome.
Sorry, got a little late.
No, thank you for joining. So I was just giving some examples of the recent flood events that have hit our region. And I've just covered the climate change studies that you had, chaired as well as led as part of the HIMAP report. So the Chamoli disaster, right? So this was, as I said, in February 2021, but this led to huge damage downstream. And there was a huge flood that occurred. And as a result of the flood, many of the hydropower projects that were there, at least the two I can name of, were completely washed away. And then more than 180 people lost their lives. Similarly, yes, the Himachal floods of July 2023. And this is quite timely to show this because, IITM has just had a visit from the Himachal Pradesh, from various departments, including, I believe, the additional secretary himself was here to discuss, some of the ways to address minimizing the adverse impacts of such kind of disasters. And these are mainly the flash floods that are occurring in higher elevations, particularly due to high intensity and short duration rainfall. So another example I would like to show you is the Melamchi floods. And this flood occurred in Nepal. And this was, again, a high elevation. It's starting quite high these days in terms of the glacial lake outburst floods and flash floods. And here, this was more of a cascading hazard leading to cascading disasters. So when we talk about the hazards, what is really happening these days is that it's not only one type of hazard that is occurring, but there are multiple hazards that occur in a chain. So here the floods was originated from the glacial lake outburst flood. As a result of the glacial lake outburst flood, landslides occurred. As a result of the landslides, it blocked the river. As a result of the blockage of the river, a lot of water was impounded behind this artificial dam that was created. Then a sudden release of the water from this dam then resulted in even larger floods downstream. Yeah, so this is what we call as cascading disasters and cascading events. And so it's important for us now to consider not looking at only one hazard, but multiple hazards in cascades. And that is gaining a lot of attention as well as happening these days. So here, unfortunately, there were not there were 25 people killed, but not in hundreds, fortunately, because there was some kind of an early warning in the basin, but that was also very much community driven. It was people in the upstream, calling people in the downstream through mobiles, informing them of the floods that are coming. So it's important to have that network in the community in terms of sharing of early warnings. And then this resulted in huge aggradation, more than 15 meters of aggradation. So if you talk about 15, that's like 3 stories or so, and large, huge boulders. Yeah. So that's the Melamchi floods. But again, I'll show you one slide here because we need a lot of data and information. And when you talk about climate change, variability, spatial variability, temporal variability, it's important to see what kind of data and information are available. Fortunately, in the case of the Melamchi disaster, there was one automatic weather station located quite high up, about 4,000 meters. And this was a weather station that was operated by ICIMOD. Yeah, so we got this data and basically were able to show what really happened. I mean, there was high rainfall in higher up catchments. So this is also something that needs our attention. That is, the rainfall that was occurring earlier at lower elevations are now, going up. So the more the wet rain, you find that it's going up at higher elevations. I'm sure our data also, here also shows that kind of change that is happening. So what are some of the challenges that we have? Yeah, given this kind of introduction that I have given in terms of the different hazards, the typologies, the disasters that have occurred, what it shows us is that, yes, there is no doubt there is an increase in the intensity as well as the frequency of these extreme events, of these disasters. And this has been also sounded very loudly in the IPCC AR6 report, that there is going to be an increase in the intensity and frequency of events. Another important point is that the network density that exists is varying. If you're looking at it in higher elevations, there's very, few network or few stations. The network is very poor. And if you're looking at it in the lower elevations, it's better, but could be improved. Yeah? So there's a need to improve these observation networks in higher elevations. Particularly, this becomes important when you are running our numerical weather predictions, for instance, or doing some kind of a validation of the work that we are doing, simulations. we do require observations where available. And the more the observations available, the better the validation, the better the modeling results. Then whatever data that is available is also not easily shared. It's quite difficult, actually, because it's also to do with a lot of mindsets in terms of sharing of data and information. I mean, it is happening gradually, but again, it is quite difficult to share these kind of data and information. And we realize that the capacity in the region, the Hindu Kush Himalayan region, in the countries of the Hindu Kush Himalayan region, is also varying, whether we talk about climate services or the hydromet capacities in our region or the research capacities. We can compare, for instance, China, India, Pakistan. I named the ones that are good, but then you compare it to Nepal or Bhutan, right? Or Myanmar. There, we have a lot of challenges in terms of research as well as the information that is available, the capacity that exists in the region. And there is an opportunity then to build those capacities and then share the data information across these institutions and organizations. But there are a number of sectors which are, affected by climate change, for which climate services is required, right? But climate services also needs to be tailored to the needs of the users. And you cannot just provide data or information and expect that it is going to be used by various users. It has to be tailored to the needs of the users. And here, it has to be actionable and also gender responsive. I put in this important stress on the gender aspects, the gender responsive aspects, because when we're talking about people affected, it's men, it's women, it's elderly, it's the marginalized people. And often those many of them are left behind. So we need to have that lens in terms of looking at how best we integrate the aspect of inclusiveness into our climate services and tools that we develop. So with that, I think we need to also look at what do we mean by climate services? I did say climate services loosely, but again, what is the definition of climate services? So the climate services, the definition that the World Meteorological Organization has provided is that it's a science-based information and forecast that empowers decision makers at different levels to manage the risks and opportunities of climate variability and climate change. So it's both the opportunities and the risks we need to manage through the climate services. So here we're looking at an entire chain. You're looking at it in terms of the production of the data, the information, then curating that, analyzing that. And what is also important to consider is the packaging of this information into products that are, again, easily usable for operational purposes as well as for policy and plans. So this whole process then is the climate services. So, this is a very, familiar slide to all of you here because we are talking about it at different temporal scales here and the spatial scales. Yes, spatial scales, we're talking from global to regional to national and then to the local scale. And then time scale from the data that's available historically to then the daily, weekly, decadal, and then we go on more in terms of seasonal and then the climate time scale. Yeah? So all these different time scales are available. And here, these time scales would be important for then the use for different purposes. You have for weather forecasts, for weather time scale or seasonal forecasts, sub-seasonal forecasts, particularly looking at for agriculture purposes that would be required. And then more the climate projections and the climate time scales more for planning purposes. Yeah? So this is just an introductory general slide looking at the spatial and temporal scales. So now I would like to give you some examples, again, I take you with that introduction, give you some examples of what ICIMOD has done in terms of addressing some of these gaps. So one of the examples I would like to share with you is the HKH HYCOS project. So the HYCOS stands for the Hydrological Cycle Observing System. And this was particularly in collaboration with the World Meteorological Organization, WMO, and this was part of the HYCOS program. So under the HYCOS program, we had the HKH HYCOS. Similarly, they have the Mekong HYCOS, they have the Aral HYCOS, they have the SADC HYCOS for South Africa. They have many different regional HYCOSs. And the focus here is looking at data and information and making that available and looking at some of the latest tools and technologies that are available in strengthening the capacity of the hydromet networks. So as part of this project, we worked primarily with 6 countries, Pakistan, Nepal, Bhutan, and Bangladesh. The 4 countries were more the implementers, while India and China were observers to this project. And the focus was to strengthen the hydromet capacities, looking at modernization of hydromet networks. So this project actually started real-time data transmission across the 4 countries. Yeah, so this is one example I thought I would share, important in terms of getting raw data or ground data for our validation purpose. This started in end of 2010, and then we completed this in 2017. So as part of this, we had real-time data coming in information systems from all the 38 stations. But over the time, these days, that's why I stress on operation and maintenance. Over a period of time, these stations now have been upgraded by the countries, and then other stations have been put in place. And as well as the World Bank has come in and made a huge investment in Nepal, in Pakistan, in Bangladesh, in Bhutan, in millions of dollars to upgrade the hydromet networks. So that was a result of that. So there needs to be projects like this that helps. Here, I'll take you to the very local level, from the regional level to, again, the very local level, where climate services becomes very important. And here you can see in the photograph, there are ladies that you can see raising their hands, are those that are receiving the agromet advisories. Yeah, so, and these advisories are being made available, one, through these mobile phones. So these agromet advisories, there is a mechanism in place where these agromet advisories are generated and then shared with the farmers through SMS. And then we also have a dashboard, agromet information dashboard, which is then used by a committee, a technical committee, which is then analyzing the data that is coming, the meteorological data from the Department of Hydrology and Meteorology, as well as other sources, and then the data from the field regarding the health of in the farm, the crop health. So they make these advisories. So this is being used. So this is also at the very local level. And I think IMD is doing quite a good work in terms of having this agromet advisories go at very local levels too. So there are many things that could be learned there. But one of the things that always becomes a challenge here is the local information being available. Like they'll say, for our area or for our region, how much is it going to rain, for instance, or how much is it going to flood? So very localized information they require. And that is always a challenge with the models that we currently have. So I will give you another example. I think some of you are familiar with the Asia Regional Resilience to a Changing Climate. This is a project with Met Office, UK Met Office, and this was a project from 2019 to 2023. So we just finished this project. So the focus was improving the applications and access to weather, seasonal and climate information and services, new technologies, and then linking science to society. So the SASCOF actually is part of Work Package 2, and SASCOF has been supported by the ARC project, while ICIMOD has been part of Work Package 1 and 3 and 4. So one is on impact-based forecasts, which is gaining a lot of attention too. It's not only what the weather will be, but what the weather will do. Yeah, so that's what is important. And then the Work Package 3 is more the climate time scale, where we have the institutional capacity building. So this, I will not read out the whole thing. And this is an example from the farm. And this is from Pakistan. And there was this study that we did in terms of the valuation of the socioeconomic benefits of climate services in Pakistan, in 2 provinces that we did, in Sindh and in Punjab. So, and particularly we also focused on women farmers to see whether they are also receiving the information and how they are also using it. And very interesting results from the study, by the way. We do have one paper that has come out. Be happy to share if anybody is interested. But with the services that are being provided, many of them at the very higher level found less value, while really going into deeper, into more of the individual level, then that's where the benefit lies. So it has to be really disaggregated. So now I will go into this more in terms of the regional climate projections of ARC, more the ICB, that's the institutional capacity building. So when we talk about the institutional capacity building, and this was supported by ARC, and here we partnered with a number of different institutions, like you can see, UK Met Office, we had the World Climate Research Program, and then we also partnered with IIT and Pune here. We have Dr. Sanjay, who's leading the team, and many that were involved in terms of building the capacity and introducing the CORDEX WAS, we call it, South Asia data sets to the countries in the Hindu Kush Himalayan region. And so this particular approach, basically, it's important that the partnerships start right from the beginning, first by identifying some of the issues and problems, and then looking at the series of capacity building activities, and then developing certain tools to support the countries in terms of making analysis, particularly climate change indices analysis. Yeah, and then co-generating knowledge at the national level, particularly for sectoral applications. Now, this is the roadmap, the evolution to the roadmap. And here you can see first, service area selection in terms of climate change projections. So this started by first consulting with the various regional stakeholders, and where climate change projections was identified as one of the issues that needs to be addressed. And then with that, we identified some of the key institutions. Then we had a capacity needs assessment to evaluate what the capacity of the region is and what is required. Because before launching any capacity building activities, as you all may be aware, we need to do that evaluation first, the assessment, in order to address the needs. Then we had series of these events, started off with an online training in October 2020, because that was just during the COVID period. So we had to do some of the trainings online, and then a series of trainings depending on the needs of the countries. We first thought that it could be good enough just to do a regional level training. We had the regional partners come in, and we started doing while we're doing the online, we realized that it was very difficult. Why difficult? Because the capacity of the countries varied so much. While some of them were already ahead in terms of some of the tasks, some of them were still struggling to even load the software. Yeah, so it was the capacity of the countries, but also infrastructure that are available in the countries in terms of downloading, in terms of running the models. So it really needed very focused attention at a country level. So then we had country level programs and trainings starting from Nepal, then we had for Bangladesh, and then also for Bhutan. So, this is an example. Here I show, I list some of the trainings, but this figure here that you see are the 17 models that are there in the CORDEX simulation. So the CORDEX was based on the CIMEF 5. There are 17 simulations. We took all the 17 simulations and then ran the model, and then we were using R codes. Yeah, so that has been developed by my colleagues. So R codes were being used where the different countries that came for the training were then introduced to the R codes. Fortunately, one didn't need to go too detailed into understanding each of the codes, but again, sufficient amount of understanding was needed in order to run the R codes to get your results. So this was done in partnership with many of the partner organizations like Bangladesh Meteorological Department, also Bangladesh Water Development Board, Department of Hydrology, Meteorology, and Bhutan also, National Hydromet Agency. So these were there. And then the reanalysis data sets that we used to compare or validate these data, the CORDEX data sets, were, we also used Aphrodite, and that was available. But again, later opted to use different other, like ERA 5 was also used. But apart from that, there were also some observed data sets that the countries had themselves that they could use. Yeah. So this is, I just wanted to give you what the structure of the training was during these presentations. So during the trainings, there was this fundamentals on climate change, science and prediction, and introduction to the CORDEX datasets, particularly the ones that IITM was leading and has generated and is available in the website here for download. And then the CORDEX data extraction and management and analysis. So this was a whole day's training. Then the representative model selection, because there were more than 17 model data available, of simulation data available. So all the 17 simulations were not used, we selected like 4 simulations for a particular analysis or run, like for instance, extremes, in looking at certain criteria which was discussed and then used during the training. For instance, looking at the shape of the hydrograph or the volume of the flow of water. Yeah, and then we did also the indices calculation. Number of different indices were used, like RX 1 day and then RX 5 days for extremes. And then for others, as was required by the sectors, they used different indices. For the hydrological community, they had different interests. And then the ones that were working on agriculture or health had different indices. But there is a series of different indices that are available that can be looked into and then chosen. And then we have this particular software available that can be easily downloadable and used. So I put in this particular slide of RIFS, yeah, the Regional Information for Society, because this is the transition now that CORDEX is making, the whole overall kind of structure that is in place even at the World Meteorological Organization, as well as far as WCRP and the small work that we've been doing, the My Climate Risk program, for instance, that Roxy was a part of and is still a part of. So within that, I think this the Regional Information for Society has been then, I call it evolved or born, and the main focus of this is linking climate data and information for societal use often what has been faced and is a challenge is that data and information is being created. Yes, there needs to be a lot of improvement, but whatever is being created is also not reaching the community or the people. So how do we bridge that in terms of making information available for the society? So that's how this RIFS was seen and developed. So it's to bridge the gap between climate research, climate information used for decision making at various levels, particularly for the society. And then so CORDEX is a part of RIFS. Yeah, so this is the new development. It's just for information. And then finally, I thought I also would like to share with you some recent developments from the World Meteorological Organization again, is that similar to the SARS-CoV, there is also a TPRCC network. Okay, TPRCC network is termed as the Third Pole Regional Climate Center Network. Yeah, so within this network, I mean, this is under the world being led by the World Meteorological Organization, with 3 nodes, with the overall leadership lying with the China Meteorological Administration, being the northern Third Pole node, and then we have the southern Third Pole node as IMD, and then the western Third Pole node as PMD, the Pakistan Meteorological Department. So we have the China Meteorological Administration, India Meteorological Department, and the Pakistan Meteorological Department. So this is a very, very, very recently evolved network, which is taking shape. The first forum has been held, and as an outcome of this forum, it's also an outlook that is being generated. And this is for areas like you can see above 2,000 meters. So this is more focusing on cryospheric parts and less on the lower altitude issues. Yeah, so I just thought I'd share this. And Dr. Kohli has been very instrumental in terms of bringing the experience from the SARS-CoV and overall lead that he's worked with the regional climate forums. Key messages, yes, to end with, yes, extreme events are on the rise, and that we see that there is a need to co-develop solutions, co-design solutions, particularly if you're looking at the users. And science-based evidences is required to be tailored. So tailored climate services is required for information to be actionable and understandable. And the institutional capacities, they need to be built and also documented. And finally, I'd like to stress in terms of, since we are talking about the whole Hindu Kush Himalayan region and talking about weather and climate, it's essential that we have regional collaboration and with strengthened international partnerships. Yeah, so with that, I end my presentation, but I'd like to thank again Dr. Krishnan for being here, and also like to say how much we have benefited from Dr. Krishnan's leadership in terms of helping us better understand some of the challenges that the region faces and bringing in some of the latest tools, technologies, and understanding which relates to, climate change and with the assessments that have been conducted in the region. So we've highly benefited from that, and as well as other kind of initiatives that we've worked in the past. So thank you very much.
Thank you, Dr. Thank you.
Thank you very much, madam, for taking us through the importance of climate services, especially over this very important region. So can we take a couple of questions? Sure. Yeah, it's open to, please.
A wonderful presentation. It's always a pleasure to see you and hear from you. I want to pick you on your last line on regional collaboration. I would like to know what progress is there, especially since we are dealing with Himalayas, where we border a lot of countries which are generally in conflict, or there are some other issues as well. So what kind of progress are you seeing in terms of sharing data? For example, I worked with teams where river data was an integral part of that project, but it's these rivers are sometimes coming from Nepal or China or some other country and flowing through India and so on. So if you need to understand the dynamics, the flow, hydrology, and so on, we need to have data exchange and so on. That's just an example. So I would just like to have an overview from you.
So thank you very much, Roxy. Very important question. Yes, definitely, in terms of looking at what progress has been made in terms of regional collaboration in the region, particularly talking about, like you mentioned, sharing of data, information, knowledge. So yes, like I said, there are a number of challenges that do exist when we talk about sharing of data and information. But again, a lot of progress has been made. The example that I provided just recently is the Third Pole Regional Climate Center network that has been evolved and is a way of addressing some of those data gaps. And there we are more looking at the cryospheric data sets. Yeah? And in terms of the tools, the technologies that are in place, also the satellite-based data that are available is making a lot of gap filling. I'm not saying it would substitute the ground-based data, but there is this opportunity to look at ways of addressing some of those data gaps. So international collaborations with organizations that provide such kind of satellite-based data and information helps us then to look at ways of narrowing the gaps that we have. So as we, work in terms of addressing the challenges that are there in place of looking at how best the data can be shared, we can make baby steps. I say baby steps because every small program or every small project, even the high costs that I mentioned, for instance, where real-time data was being shared from 4 of the countries, is an example of regional collaboration for saving lives and property. The Third Pole Regional Climate Forum, or even the CORDEX, where we are looking at these climate scenarios and looking at some of the common tools and methodologies to help the countries have the common understanding as far as some of the challenges and issues are concerned. So small baby steps and we will slowly get there, is what I would like to say.
Thank you, Dr. Mandira. It's a very nice talk. There was one university that was supposed to come, no? That Himalayan Consortium or so. What is the status of that?
Yes, thank you very much, Dr. Krishnan. Yes, I did not mention the Himalayan University Consortium. In short, we call it the HUC. So that is a consortium of more than 90 different universities across the Hindu Kush Himalayan region and around 40 organizations and universities from abroad, from outside the Hindu Kush Himalayan region. They have formed the HUC, right? So as part of the HUC, there are various thematic working groups. So thematic working groups on disaster risk reduction and resilience, for example. There's a thematic working group on water. There's a thematic working group on cryosphere. There are various other thematic working groups also looking at some of the indigenous knowledge, heritage, many actually that are, as the interests from different stakeholders come in, these thematic working groups are being formed and formulated. But here what I would like to stress on is that these thematic working groups are led by the universities or the institutions, not by ICIMOD. So there are these leads and co-leads that run that particular thematic working group, working on common areas of interest, and also holding different workshops, events. You might question where the funds might come in, because that's always important. So there it's some part of it is small funds being made available by ICIMOD, but also from some of the partnering organizations are also coming up with funds. And also there are some joint projects and programs that are being developed, which also is a source of fund. Just about, I think, 20 days down in October, towards mid of October, there is a program in Wuhan, China, on the project called Hydro Himalaya. So that's a project for the hydropower sector funded by the Norwegian government. So that's just an example, looking at building and strengthening the capacity of students, particularly PhD and masters, on hydropower development. And there I have two students, so one a PhD student and another one a master's student, focusing on hydropower development.
So it is already in the formation stage.
Yeah, it's already in the advanced stage, but now it's slowly going towards autonomy. So there is this 3-year period that has been provided to look into how HUC can be autonomous and serve the Hindu Kush Himalayan region together with that large network that is in place. So it's the value of the network, basically, and how you mobilize that network. And I think it's very important because many of the knowledge, the latest tools, technologies, comes in from these universities, these research organizations, and then how you feed that into the real work that is being implemented is something that also needs to be, greater attention. That's where ICIMOD interfaces in terms of, linking science to society, being that interface and providing that kind of a platform.
Thank you.
Is there any other questions? You have something? Is there any questions?
Students might have some.
Yeah, students. Any question, any clarification needed? Yeah, otherwise we are facing a lot of extremes, especially over our Indian Himalayan states. So you also mentioned a lot of events happening over Nepal. So what is the ground reality there, madam? So events are really increasing. No need to have such question, but still you can give some glimpse of what is really happening in ground in Nepal in terms of extremes and how you are managing it. So for example, in India, we have a state disaster management or national disaster management authorities there, at least to manage such events. So can you give us some light on what is the status of Nepal?
So thank you, Dr. Savin, for that question. I'll dive into it. Yeah, because when talking about extremes, yes, I mean, there's no doubt, yes, the extremes are rising. Yeah, the examples that I just showed you in my presentation speaks, Another example maybe I didn't include in my presentation is the recent event in far west Nepal, which occurred in July. 630 millimeters of rainfall over 24 hours in one particular location, not very large, with a intensity of more than 90 millimeters of rainfall in 1 hour. Yeah, so that is talking about, really extreme events that are there. And this is not just one isolated event. There are many such events that are happening that are testimony to the fact that, yes, the extremes are rising. And now what are we doing with it? Or what are we doing about it? Well, one of the important things that is important for us to look into is what is it that we have in terms of better preparedness of such kind of extreme events. One is, of course, we need to see how we have improved our forecasts, right? What is our forecast telling us when it's saying it's going to rain or heavy rain? Is it raining? These are the questions. But there's no doubt nowadays that there is so much of improvement in our numerical weather simulations across the world, in each of the countries, that, the detection is getting very good, detection of heavy rainfall. So, but what is, I guess, needing more attention is more the localized information, more zooming into certain areas. We can say overall at the district level or at a certain pixel level, there's going to be high intensity rainfall, large pixel area, I'm saying. But going into very finer resolutions, there is this gap still. And when I go to the field, many of the people are asking, what is going to happen now here in this place? Can you tell us? We need this information 3 days in advance or 3 hours in advance, depending on where you are. So that kind of finer resolution. So there is this need to improve our research, our capability, our capacity, numerical weather simulations in terms of making those better forecasts, both at the weather time scale as well as the subseasonal to seasonal time scale as well. And the other fact that we need is that early warning systems. Do we have adequate early warning systems in place? Yeah, some of the locations actually do not have early warning systems. So how can we prepare ourselves better by putting in place these early warning systems? So when we talk about early warning systems, then again, what is that? We're talking about 4 major components. One is risk knowledge. Second is detection and warning. Third is looking at information dissemination and communication. And the 4th pillar is looking at response capabilities. Yeah, so there's 4 pillars when you talk about early warning systems, where all of them are important. So it's important that you know where the risk is. The communities need to know, whether they're staying in very risky areas, risk zones. The government need to identify those risk zones, make sure that people do not live in those risk zones. If they're living, what are the options? Those kind of things comes part of the early warning system. Then detection and warning, which I think we are part of, IATM as well as IMDs, they're more at the weather time scale. How do you prepare, make better kind of forecasts so that you can make that 3 days warning to the people in the community. But that's not enough. You need to also ensure that it's communicated and disseminated well. Yeah, it needs to be actionable. It needs to be understandable. So these kind of so then you have the response capabilities. So it's a whole chain. You need to have a whole chain that needs to be very much strong and strengthened. Yeah, if one of the chain is weak, then you're going to be not, not saving lives and being adequately effective. So we need to have that early warning system in place from higher elevations, like giving the example of the South Lonak Lake. Unfortunately, there was no early warning system, functional, I call it functional early warning system in place. So there has to be this functional early warning system in place. It has to be operated well. It has to be monitored well. It has to be managed well. And so there are so many different actors. So we need to look at the whole continuum of actors to make sure that, we are addressing these extremes well in terms of our main goal is to save lives and property. So yeah, so in Nepal, we have the Department of Hydrology and Meteorology, which is then collaborating with a number of institutions. Also, they are improving their capabilities as far as making better warnings available to people and communities. Yeah.
Thank you, madam.
And ICIMOD supports those activities, of course.
Yeah. Thanks a lot, madam. It was really nice to get all the information from a person like you who is having a lot of experience over this region. So let us thank the speaker once again. Please give a applause for that. Yeah, thanks a lot. Thank you.
Can we have a group photo with Sarah here? That is like.
Yeah, please.